Symbology of the Bible, Volume 2. The Multiverse. As with the recent VGR1 news, there have been some incredible observations from the James Webb Space Telescope, JWST. Specifically, it has observed fully formed galaxies at the farthest distance ever, which coincides with the farthest back in time. The time at which the observed event occurred for deep space objects is determined by the redshift of the observed light. One source provides the following.
About 13.8 billion years ago, our universe began with a Big Bang. But this initial rapid expansion started to slow down almost instantaneously due to gravity. However, our universe's expansion rate began accelerating roughly 5 billion years ago due to a force called dark energy. Evidence of this expansion comes from observing the spectrum of colors emitted by galaxies. As space expands, galaxies move farther away from each other, and their light elongates while becoming a redder color. This phenomenon is called cosmological redshift. The greater the redshift, the greater the distance the light has traveled.
The redshift factor, Z, is found using the following function. Z equals the observed wavelength minus the known wavelength, all divided by the known wavelength. The velocity, v, of the detected photons can then be found using this function.
V equals z times c, where c is the speed of light.
This velocity represents the radial speed of the receding source, since the universe is expanding, which is the speed of the galaxy observed. By finding z, the age of the universe, when the observed photons were emitted by the source, can be estimated. Astrophysicists use the following function to do this.
T equals 1 over h naught times the quantity 1 plus z, raised to the 3/2 power.
We see that the age of the observed galaxy is inversely proportional to the Hubble constant, h naught, which is about 70 kilometers per second per megaparsec. According to one source, the farthest galaxy ever observed to date has a redshift factor of z equals 13.2. The picture below shows the galaxies and is followed by a piece of the article. Of the four, the most distant is one with the somewhat unwieldy name, Jade's GS, Z13-0. It has a redshift value of 13.2, meaning we are seeing the galaxy as it appeared, just 320 million years after the Big Bang. That high redshift makes Jade's GS, Z13-0, the most distant currently known in the universe, a record that JWST seems set to imminently break again, but one that highlights why astronomers are so thrilled. We now know for certain that we are probing an era of the universe no human has ever laid eyes on before. It's astonishing, says Peter Van Dockum of Yale University. This galaxy, he evocatively notes, is only slightly older from our perspective than the total time sharks have existed on Earth, some 300 million years. You go from nothing to these fully formed galaxies in the blink of an eye, Van Dockum says. While the galaxies don't yet pose problems for leading models of cosmology, they suggest that galactic formation began earlier and proceeded faster than expected in the universe, which theorists had previously predicted began churning out galaxies at the ripe age of 1 billion years after the Big Bang. redshift, can be explained using an absorption spectrum, as shown below. The dark horizontal lines indicate a wavelength of photons that are absorbed, thus a black line. The picture of the spectra shows the known absorption spectrum on the left and the spectrum observed by the telescope on the right. The new wavelength of the known wavelengths element can be determined and used in equation 1 to find z. For high-velocity objects, velocity is estimated by this relativistic function.
V equals c times the quantity z plus 1 squared minus 1 over the quantity z plus 1 squared plus 1.
The age of the identified galaxy is calculated below using equation 2.
T equals 1 times 3.09 times 10 to the 19th over 70 times 14.2 to the 3 halves, which equals 8.249505 times 10 to the 15th seconds, or 262 million years.
Recall the standard inflationary model of the universe's expansion, shown below. The theory holds that stars began forming at around 400 million years and galaxies at around 700 million years. The approximate location of the discovered galaxy on the timeline is shown. The unexpected discovery has the astrophysics community looking for explanations. The import of the galaxy's existence at around 260 million years old is that it is anomalous relative to current models.
We're seeing a rise of massive galaxies faster than we thought previously, says Fabio Picucci of the Harvard-Smithsonian Center for Astrophysics. The ages of some of these early galaxies are estimated at just tens of millions of years.
Two of the proposed theories to explain the galaxies are below.
1. Conformal cyclic cosmology, CCC, championed by Nobel laureate, Sir Roger Penrose. This theory suggests our universe is just one eon in an infinite series. He argues that certain anomalies, detected by telescopes like JWST or Planck, could be Hawking points, remnants of supermassive black holes from the previous eon that left a mark on our own. 2. Multiverse and bubble theories. Some fringe interpretations of JWST's data suggest these galaxies might be visible because our universe is a bubble within a larger multiverse. In these scenarios, the impossible maturity of the galaxies could be explained by different laws of physics in overlapping regions or cracks in the fabric of spacetime, though this is considered highly speculative.
Elements of both of these theories were proposed in the introduction letters of this series of articles more than 20 years ago, and before Penrose's CCC theory, to wit, an infinite cycle of eons and higher laws of physics, aka super-advanced technology, with the affirmation of at least one other universe required. With a super-advanced technology that can create a universe, it is reasonable to propose that it can manipulate spacetime. Information on the CCC theory follows.
Key milestones in the development and popularization of the theory include 2005 to 2006. Penrose began putting forward the core ideas of CCC, specifically focusing on the transition between eons, cycles of the universe. And 2010, Penrose officially popularized the theory in his book Cycles of Time, an extraordinary new view of the universe. From the AI overview.
As a result, a logical conclusion is that The newly discovered galaxies may, in fact, belong to the parent universe, and we are now allowed to see it. Of note, the Penrose theory holds that the black hole evaporates, leaving nothing of the parent universe. It is recycled into the next universe. However, this assumes no external agent to interfere with the theoretical process. Also, if we are observing galaxies from the parent dimension, we may be approaching that time in the third day.